Anyways, good to finally meet you. So let's just
likewise.
Just start it. Kick it off from here.
All right, great.
Yeah. So Dan, I know it's very weird weather right now. Everywhere in the Bay Area, it's about 100 degrees, but in San Francisco, it's 61. So are you wearing sweaters and jackets to work, or how's it going?
It's actually 55 today, and there's no sun. It's totally cloudy. But yeah, I don't know what's going on. I was up in San Rafael last weekend. It was super hot. Went over to Oakland, same thing.
Wow. Okay.
But yeah, we stay cool here in San Francisco. The fog coming.
Well, we got Kunal. Before we introduce him, we got Kunal from Toronto on the line as well. How's the weather over there?
It's probably better than you guys. I have to convert it from Celsius. But I mean, the west coast of Canada has this unbelievable heat. I mean, I think it's in the 80s here, but I think it's 100 and something in Vancouver, which Vancouver's like London, England, right? It's always known for rainy and warm, cool weather, kind of like San Francisco or the Bay Area. Right. So we're happy over here.
Yeah.
That's good. That's good to hear. Yeah. So why don't we get started into this month's episode of Mobility Now? We're very happy to be here. Before we do that, I just want to say that we finally reached over 1,000 subscribers. That's a big milestone for us. So thank you, everyone who's listening. I hope we deliver the right content to the right people, and it really allows you to understand what's happening in the mobility world. But for now, I want to introduce myself. So welcome to Mobility Now, the podcast that looks mobility technology sitting at the edge of today, but the center of tomorrow. I'm your host, Amit Mehta, Head of Innovation at Silicon Valley Lab.
Hi, I'm your co-host, Dan Davies. We're an advanced research division of North American Lighting, which is a subsidiary of the global company Koito Group. And Koito is the world's leading tier 1 supplier of exterior automotive lighting.
Yeah, so one thing we really focus on at Koito and NAL is putting sensors into our primary real estate, which is lighting. So we do headlights and rear lights. We do about $8 billion a year in revenue. We have 25,000 employees in 12 different countries. But we're always thinking about sensor fusion, but how are you going to power these sensors as you move into the world of EVs? And today we have someone who's not only has a very good understanding of how to power these sensors, but understands how to take what we can't get enough of, battery technology, and recycle it. So I'd like to introduce you to Kunal Phalpher, the CMO of Li-Cycle. How are you doing today, Kunal?
Good, thanks. Thanks, Amit and Dan, for having me. Excited to be here and talk about batteries. That's what I do every day anyway.
Yeah, it's a pleasure to have you. So let me get started to first with, which we always do, and I'm sure the audience wants to know, how did you get here? How did you end up at Li-Cycle?
Yeah, I mean, it's been an interesting journey to get involved with Li-Cycle at an early stage. So company's about 5 years old. I've been involved with the company in different capacities for about 4.5 years. So almost since it was just an idea. I knew one of the co-founders from previous life, and I was working in the battery industry at that time. And he said, what do you think about this idea? I said, sounds like a good idea. And then I ended up becoming an advisor to the company through the early stages. And then as we raised some money, was on the first board of directors. And then it just happened, kind of snowballed from there as we kept building the business, and we're getting closer to commercialization from an R&D stage. Created this chief commercial officer role to really handle the business and customer oriented areas. And so I've been doing this role for about 2.5 years and helping to scale the business now in North America, now looking at also other markets. But before that, I was in clean tech, renewables. I lived in Germany for a few years. So I had exposure to batteries, which led me down into this deep dive in battery tech and now battery recycling.
Great. Really cool. And I was really excited to talk to you today because batteries, like Amit was saying, are an important part of sensor and sensor technology. You've got to power more and more sensors and other devices that are going to cars, which are getting more and more complicated. The car today has more electronics than the Apollo 11.
Yeah.
And EVs, though they've been around for a long time, it's only recently that they've really started to build some traction, really hit the news. People want them. There were 3 million, I think over 3 million units sold last year. So for the first time, it's an actual thing, right? And it's projected to grow. I think 3 million represents about 5% of the global automotive sales. That's supposed to increase. California is talking about having only EV sales by 2040. So I think battery technology is really important. That's pretty clear to me, but I'm really interested to learn about the recycling aspect about it. I think a lot of us don't really think about what happens to the battery after it's been used and how do we turn that into a new battery. So I was wondering if you could tell me why that's such an important part of this whole supply chain and why Li-Cycle is important as part of that process.
Yeah, makes sense. Just one comment, you talked about California banning ICE sales. I mean, Canada just announced yesterday that they've advanced that, and now by 2035 they'll ban ICE sales. So there's a lot of progress in terms of countries making moves to electrify the future. But
it's a competition now, isn't it?
Exactly.
Who's first?
But I mean, the main driver around battery recycling is that when right now your ICE car goes to a scrap yard to scrap for the metal parts, but nothing in that car is as valuable as, say, if an EV comes to one of those sites. The nickel, cobalt content and the lithium content that's left in that battery still have a very high value, and can be reused if broken down properly to make new batteries. And so one is that there's a high value material that's not really a waste anymore. It's really a resource that can be recovered. But two, there's projected shortage of those resources as we try and meet all these electrification goals. So in which way can you create that circularity or circular economy to bring those back into the supply chain? And increasingly, there's also sort of this geopolitical aspect of how do you domesticate the supply chain. So there's political aspects of where the materials come from. There's also social aspects of where certain materials come from. But in the end, I think for cost efficiency also, you've always seen, I mean, we're here in Toronto, so Ontario, Michigan, Ohio, quite interlinked with the automotive sector. You get that in the southeast of the US as well. Wherever they build the cars, typically where a lot of the parts are made, and you have this little ecosystem, right? So now in EVs, you're starting to see that with cell manufacturing announcements, almost on a bi-weekly basis right now in the US. And so how do you then create that full ecosystem? Part of that is having the raw material supply close by so that you're not digging up materials in the Congo, refining it in Asia, and then sending it to the US. Can you create another source of cheaper raw materials, particularly the nickel and cobalt and lithium, to go into batteries? But then there's also trends to then try and move away from some of those materials altogether to reduce reliance on all this complicated global supply chain and make cheaper batteries.
Got it. So I'm very interested in your business model because you're a very unique company. It seems like you just play in battery technology, and that's true. But I feel like you have the ability to play in multiple different verticals, because as we move into the future, a lot of things are powered by batteries. We're going to see a lot of stuff in healthcare. We're going to see a lot of stuff in cell phones, of course, already. We're going to see ICEs convert to EVs. Who knows what's going to happen in real estate? And you have this unique position to have different business models for different verticals. So I'm very interested to hear, specifically in automotive, but of course, if you have anything else, you can please feel free to chime in. How do your business models compare to, let's say, cell phone recycling versus healthcare recycling versus automotive recycling?
Yeah, and we're basically a part of all of those supply chains. So, on the front end of our business, it's very much like a waste management or environmental services company. But certain verticals will have different supply chains. So we're really only after the battery, and some of those verticals you mentioned we're already a part of. But for example, electronic waste, especially from corporate electronic waste, we're not into the topic of data destruction or anything. So there's groups that will take all the electronic waste, destroy the hard drives, et cetera, and then extract the battery from the device. That's becoming increasingly difficult with all these embedded devices, right? So the battery is really hard to take out of your phone. It's a very manual process. So there's opportunities for us to get more integrated with that supply chain. Also, I mean, if the main value in a laptop is the battery, and we were just to shred the battery, then the data is destroyed as well, right? So it's a 2-for-1. But we're not in the front end collection right now of going to corporates or putting boxes at Home Depot to collect batteries, also household batteries like power tools and vacuums and your Dyson and Roomba or whatever. So there's already established networks that we just partner with as a downstream process. So it's very backseat processor angle. As we get to the larger batteries, there's a different approach because there's also different touch points within, say, an EV company, right? So we can help them with obviously batteries that come off the road. I call it midlife crisis right now because not a lot are actually hitting the end of life. So they're end of warranty. We're picking up the battery from a dealer, bringing it to our site. But then there's also a lot of a certain amount of waste when you're producing cells or modules or packs for the vehicle that can't go into a car. They haven't met the QA/QC, something's gone wrong, and that can readily be recycled by us as well. So there's that touch point. But then the automotive OEMs are also trying to create a circular program or circular economy around raw materials. So they're also interested in buying eventually the raw materials back, or with their partners that are making their cells buying the raw materials back. So that's a totally different business model that can evolve also, that we maybe become almost like a toll processor. You send us batteries, we send you raw materials as the volumes increase. Those are two core verticals. I mean, we work in energy storage as well, but again, we're not going to do everything ourselves. So we have a partner that specializes, for example, in decommissioning and scrapping all the pieces from an energy storage project. And we focus again on the slice of lithium-ion batteries.
Mm-hmm.
Then you can get into commercial transport, which I think we're just, as we have conversations there, you need different solutions because you don't necessarily have a dealer network. You have a different, you're not dealing with consumers, you're dealing with municipalities or corporates as your customer. And there's different approaches on also who makes the battery versus the vehicle. There's often there's often a third party making the pack, putting it into the vehicle, like the vehicle manufacturers putting it into the vehicle, and then passing on a vehicle with some warranty to a municipality. But it's not as streamlined as, most of the vehicles have an X warranty, it comes back to the dealer,
Mm-hmm.
and then the automotive OEMs taking care of the recycling. So there's different opportunities to either partner with these pack makers or the OEMs, or even municipalities that are looking at sustainability strategies to help them with recycling of their fleet vehicles.
Got it. So just for our audience, I didn't get a chance to dive in because one of the things that one of our audience's members or listeners said was we go too in depth and too technical too fast.
Oh.
So I want to back up 1 second and explain in a very layman terms, how does a battery work?
Oh, from a fundamental,
very, very
battery.
Easy for everyone to understand how a battery works.
Yeah, I mean, basically, a battery is a means of storing energy. So you're maybe exciting electrons is too technical, but you're basically creating a chemical process that allows for energy to be stored and then used later. That's probably the most basic explanation I can think of off the top of my head.
Okay, got it.
Is it very different from, because cars have always had batteries.
Yeah.
They're different from the lithium-ion batteries that EVs use. Is it a big difference?
Yeah, I mean, you've had a lead acid starter battery for a long time. I mean, theoretically, you could make an EV with a lead acid battery. I think the EV1, the GM car, may have been lead acid or a nickel metal hydride. I'm not entirely sure, but you also see people post these pictures from 1895, 1900, where the first EV was made, right? But the challenge there is the energy density, so which enables the range of the vehicle. is very limited. So even at 500-kilometer range or 300-mile range vehicles, people have this range anxiety and are saying, oh, it's not enough range. I was on a panel or something, I think, yeah, it was a panel yesterday where people were saying we need more range, but I was saying that, even your IC car doesn't go, nobody drives, very few people drive 600 kilometers or 400 miles a day.
Mhm.
And also you need to fill up a gas tank at that point as well, right? So we're, in my opinion, we're already at this point when you're in this 400, 500, 600 kilometer range, or what is that, 200 to 400 mile roughly range. For most people's driving habits, that's fine. And so I think we've achieved, but with the lead acid battery or older battery technology, you wouldn't have got there. And I think there's probably some barrier, if you have a 100-mile range, most people aren't going to be interested, though there's probably a segment of people that drive to the train station, at least here in Toronto, but on other major commuting cities, and just take the train into work and aren't using that car more than 100 kilometers a day, right? But I think that's what the lithium-ion technology is enabling. There's groups looking at longer range. Obviously, if we get into commercial transport, it's a different infrastructure needed and range needed. But that's really where what lithium-ion has enabled, I think, at the state we're at.
So I think to summarize what Kunal said is, you're okay if you want to buy an EV today.
Yeah, I think 80% plus, maybe it's 90% plus. There's different studies out there exaggerate their driving pattern, or they think about the one time a year they maybe do a road trip, and for the rest of the time the EV range is fine. Right? I think what it comes down to is charging infrastructure. If you live in a home and you have a charger, that's fine, because you can, every day you have 500 kilometers or 600 kilometers range. Yeah. Or 400, whatever car you buy, depending on the brand. If you don't, like myself and my wife, we live in a condo, we don't have a charger, but we can both walk to work when we're back at the office. So we don't really need to drive every day. So it doesn't really matter. And there's enough, certain brands have better charging infrastructure. There's a lot of fast chargers around. And then there's also, you can leave it somewhere for overnight charge, right? If you plan a little bit.
Yep.
Yeah, it seems like a lot of those battery advancements that you talked about have been recent and really rapid. It seems like just over the last few years, the range of our EVs has increased by units of hundreds of miles. And you mentioned some of the embedded batteries that are happening in consumer electronics. There's a lot of advancements happening now. And I think with technology advancements, they tend to follow an S-curve, right? When they first start out, there's a lot of trial and error happening. And then there's this explosion of ideas, which I think is where we are now. And then the technology kind of reaches maturity, and maybe then the next thing is born. Where would you say we are with lithium-ion technology, or just battery technology in general? Where would you say we are along this technology S-curve?
Yeah, you're probably getting to a mature state in lithium-ion. Now it's almost like ice cream. They're just creating different flavors, right? Different combinations of nickel, cobalt, iron phosphate, different ratios, slight tweaks. There's different additives to help, or even on the other side of the battery, what's called the anode, they're trying to use more silicon instead of graphite. So it's slight incremental increases, but I think, 5 years ago, cost was like, I don't know, $1,000 a kilowatt hour for a pack, and now it's sub 200. People are trying to get to $100 a kilowatt hour. Some of that is also just manufacturing scale efficiencies now we're achieving, or switching out raw materials. So people recognize that to make the cars cheaper, then you can't have a battery that costs you thousands and thousands of dollars.
Of course.
Also, raw material supply is important. Where I see it going, and some of it's from what I've heard also from conversation I've had, is that you're getting to the point where you see in the last 12 months, a lot of the vehicles are being deployed. There's going to be the major OEMs are deploying 8 to 10 vehicles at a time, rather than startups that maybe do one at a time. So you have a platform where you have a lot of consumer choice. But I think eventually you'll also have, like, you have engine choice, you'll have battery choice, but obviously the consumer won't know the chemistry. They'll know based on the range, right? So for your driving lifestyle, you can choose a range which will have different chemistries, which affects the cost of the battery and also the raw materials going into it. But I think the major trend we see is that obviously people want to use be less reliant on cobalt. more for social reasons, but also from a cost perspective. So there's a trend to go back towards a really nickel and manganese heavy battery now that we've seen announced by several automotive companies as well.
Cool. So there'd be different types. There'd be like the
V6, V8, V10 type of thing, right?
Okay.
Yeah.
Cool.
So I want to move to a little bit, maybe a kind of a different subject, the threats that might affect your industry. So these are some of the things I've read earlier this week. For example, Redwood Material, Amazon invested in this company. It's a battery recycling company. Tesla is developing their own battery recycling company. Apple already recycles its phones in Austin. Another threat I was thinking of is as the batteries get better and better, you have longer range batteries that last a lot longer. And I think one of the other couple things I'm seeing is fuel cells, especially in our industry. Toyota's not fully sold on EVs, and they keep saying this. They're still pushing their ICEs and fuel cells. What do you have to say about this? And is this really a threat, or is this just something that's kind of going to last a decade and then we're going to see batteries take off?
Yeah, I think I'll handle the latter one first. I think most of the passenger EVs have moved away from fuel cell. I think even Honda was one of the last ones besides Toyota, and they're really very committed to electric. I think fuel cell has its applications in like very heavy duty applications where you can build out the infrastructure, like a brand new warehouse with forklifts. You can, like what Plug Power is doing, you can put a fuel cell in. And or in kind of hybrid situations, I think like a train or something where it still has another power source, but the fuel cell can supplement that. So that I think maybe in long range transport we see it eventually, if you can really build a hydrogen infrastructure to fill up, because you can fill up quickly. But other thing to remember is that fuel cells also have a lithium-ion battery. So the bigger the fuel cell, the bigger the battery. So there's still opportunity there.
Right.
I mean, we used to, when this 1,000,000-mile battery announcement came out, everyone was asking, what does that mean for recycling? But I mean, in the short term, a lot of our business is going to be generated from that scrap I talked about from production of batteries. So that is a big chunk of the business, and we probably won't until the end of the decade, when all these new vehicles start selling, see actual high volume of material coming off the road. So if you build a cell manufacturing plant, they often have 5 to 10% of the materials going to scrap, but then the other 95% is going into vehicles, and that 90% is going to come off the road in 8 to 10 years. So the scale of the problems 9 to 10x as you go 8, 10 years down the road. Mm-hmm. And you talk about then threats. I mean, the companies you mentioned are really competition, but the scale of the issue is so large that there's going to be room for multiple companies to work on this problem and continue to evolve the market.
Got it. Thank you.
Yeah, you mentioned, I want to go back to your comment about lithium-ion technology kind of reaching near maturity where the improvements are incremental, like new ice cream flavors. Fuel cells are going to be a part of the mobility industry going forward, but maybe they're not going to take over and be the main go-to energy source. Mm-hmm. I think maybe looking 20 years ahead from now, how do you see the mobility industry changing in terms of how we power our vehicles?
I mean, the next one that everyone talks about, of course, is solid state, still lithium based, but will help to a certain extent drive some costs down, extend that range. And we've seen major announcements or investments in groups, even by the automotive OEMs. But I think you're still 5 to 7 years out before there's scale, and even getting those on the road is towards the latter part of the decade. But our business is well positioned. It may be not the same technology, but we know we can position ourselves to handle solid state batteries. But that's one that's.
Can you explain what that is?
It's the same components, like a lithium, and there's still similar nickel and cobalt in it. Mm-hmm. It's just there's no liquid electrolyte or liquid component, which is the flammable part in lithium-ion batteries. So from a safety point of view and also energy density point of view, there's significant improvements through solid state batteries. And we've seen I can give examples like Solid Power, QuantumScape are some of the bigger names in the US where automotive OEMs have invested in them. But we're still a ways away before we see that on the road in a vehicle. So that's definitely something we pay attention. I mean, 20 years from now, I don't know, there's probably something in a lab somewhere that is going to try and supplant all these technologies, but it takes time for those to reach maturity and then scale. So anyone's guess, I think, is better than they're trying different things, of course, with different materials like sodium and sulfur and others, but I don't know if anyone would bet anything on what's going to be out there in 20 years. I think the way, and maybe it's more related also to our business, the way we use mobility may start to change with more autonomous vehicles, and how ownership of vehicles for the next generation changes, I think is a bigger 20-year swing.
Right. Then the way we drive is changing, right? And input we need to have into the vehicle is what we're
right. And I'm curious if this EVOTL, or I always forget what it stands for, electric vertical
takeoff landing.
Yeah. I personally am a bit skeptical about that. I don't know how you deal with, it's autonomous, but even autonomous cars hit each other. What happens with autonomous taxis in the air hitting each other accidentally? I'd be scared at the current situation, but technology evolves, right?
Right. I'm a little worried about our future as well, because one of the biggest threats for us in terms of lighting, we're in a great path right now because a lot of the components for an EV are going away, but you're always going to need lighting. And lighting is pretty much what brands a vehicle, right? You see that Tesla coming down the road, or the BMW, Lexus, you can easily identify and distinguish that from the lighting. But one thing I'm really worried about is we're adding more and more components to our lighting, and the power budget that we're allotted is going to decrease in the future. Is that something an OEM or a tier one should worry about? Or do you see battery advancements getting powerful enough that, look, it's okay, whatever you need to put in there is fine?
Yeah, as you make the battery more robust, there'll be more ability to power sense. As you said, I think, Dan, at the beginning, there are more and more sensors on the car, et cetera. So they must account for that, and obviously it takes away from some of the energy generation. But I guess your headlight sensors, et cetera, are they actually powered from in an EV? I don't actually know. Are they actually powered from the main drivetrain battery? Probably not. There's probably there's an auxiliary battery, or these 48 volt systems.
But overall it'll be something connected to the main drive. So that's our issues today, but we're working towards that because our power consumption is still pretty heavy.
I'm not too in depth in how much consumption your sensors would take, but I imagine that they would account for this because a lot of the EVs are trying to be autonomous ready, right? So it's not just sensors, say, for the lights or the wipers, it's the sensors for all parts of the vehicle that are going to take up, and there's just more and more electronics to power in the vehicle to make it smarter, right?
Yep.
Power is kind of the new specification that everybody's worried about, right? When we talk about automotive, I think it's still cost number one, and it always will be, as far as the performance and the features of components like sensors or actuators. Power is going to be the number two consideration, I think, going forward.
Yeah, I think time to market and power will be number one for a little bit, then cost will come down, just like we see that the cycle of where you try to cost down at some point. But for now, it's going to be power and time to market. So yeah, I think we're headed in the right direction. To kind of last couple questions, one of them is, personally, are you bullish on autonomous driving, or do you think there's still a long way to go? Not related to batteries at all.
Yeah, I think there's a lot of companies looking at it. It's you haven't, in the Bay Area, you see some of those vehicles like the Zoox vehicles around, but I think it's still early stage, and it'll take time. Personally, what I always think about is then what happens, and I'm sure the lawyers are looking at this, but what happens if an autonomous vehicle and a human-driven vehicle get in an accident, things like that, and who's accountable and things. That I think there's a lot of legal issues besides the technical issues associated with it. But I think I mean, you saw it, when we were younger in movies like Minority Report, but I think it's actually feasible now, and is more efficient, I think, from a traffic point of view, right? Because the cars, if they can talk to, that exactly what every other car is doing, you can drive closer together. There's less sort of log jam, and maybe that makes better use of the vehicles, right? A lot of cars, if it's shared autonomous vehicles, a lot of cars are just sitting in driveways all the time, right? So you're making better use of the resource, and then actually, so you have a scale up of EVs that you need, but then eventually you may need fewer vehicles on the road.
Yeah, makes sense. So yeah, the final question that we always ask is, for those who are trying to get into the industry, let's say specifically battery technology, what do you recommend specifically for new grads or students who are just coming out of school? How should they prepare themselves for the future?
Yeah, I mean, I think it's becoming quite like any other tech job. I mean, in the early days, we probably hired, even on the commercial side, more engineers, but it's not necessary to only be an engineer to work in this. You need all the different functions of a traditional business: sales, marketing, finance. And you just have to identify a company. I think, like anything in your career, identify a company you believe in and a mission you believe in, to try and work your way in. I mean, I would say comparing Canada to the US, there's probably different opportunities, more regionalized. I don't think, although the traditional OEMs are looking for all those skills, if you're a software engineer or whatever, to get into this business. But I think that it's not like there's opportunities in every city for this. So you have to be maybe a little flexible on where you want to live to get into the sector.
Great. Thank you very much for being with us today. Once again, this is Kunal Phalpher, CCO of Li-Cycle. I know I said CMO at the beginning, but I'm sure you do both.
It's okay. Yeah.
So it all comes together.
Yeah.
And please join us next time, where we're going to host CEO of Kite, Ludwig Schoeneck. So thank you very much, and hope you enjoyed this episode.